going to pretty much do the same thing, except we're going to use this knowledge we know about stoichiometry and going to moles first to deal with solutions and stuff like molarity. So in this question, we're asked to calculate the volume of a 0.225 solution of potassium hydroxide, that's required to react with 0.215 grams of acetic acid, according to the following equation. So in order to use the molarity equation, we need moles of this potassium hydroxide. So that's what I'm going to try to get first, is moles of potassium hydroxide. So I'm going to start with what they gave me, 0.215 grams of this acetic acid. I'm going to find the molar mass of the acetic acid, so I can change grams to moles. Then I'm going to use the conversion factor, the proportion mole to mole ratio. All these have ones in front of it. It's a balanced chemical equation already. So for every 1 mole of this acetic acid that we have, we're going to have 1 mole of the potassium hydroxide that we need our answer for. So when we calculate all that out, we get 0.0035798 moles of KOH. I like to keep a lot of numbers when I'm going in between steps, and the final step is what I round to the correct sig figs. All right, now we can use our molarity equals moles over liters to finish this problem. Because they gave us the fact that we had 0.225 molar KOH solution, they wanted to know the volume of that KOH solution, and we just found we had this many moles of the KOH solution. So when I solve, I get 0.0159 liters of this KOH solution. Now I can transform this to milliliters, and if you did, just make sure you write down that it's 15.9 milliliters. The units make a difference whether this is going to be counted right or not. Okay. Then we have another one. If I wanted the volume of that molarity of HNO3 solution that's needed to completely react with 38.6 milliliters of 5.15 molar BaOH solution, then we're going to kind of need the same thing. We're going to need the moles. Okay, we are going to need the moles, and this time we're going to need the moles of both of them. So I'm asking about the volume of this one that I highlighted in blue, this HNO3. So I'm going to start with the other one. I'm going to start with the fact that molarity equals moles over liters for this BaOH. So we have 0.515 molar BaOH. We're going to need the moles of the barium hydroxide, BaOH. And we have the milliliters, which I like to convert to liters because that's the way I was taught. Liters. And that's the only way you're correct when you get the moles here. Okay. So when I solve for this, I end up with 0.019879 moles of this BaOH. Now that I've got moles, I can use my equation to go from moles of one substance to moles of the different substance. So I've got BaOH2, and I want to go from HNO3. So we're going to use the equation to say that for every 1 mole of BaOH2 that I have, I'm going to need 2 moles of HNO3. which causes me to need 0.039758 moles of this HNO3. Now that I know how many moles I need, now I can get to volume by once again using molarity equals moles over liters, but this time I'm going to deal with the HNO3. I have 0.246 molar HNO3. We know the moles, 0.039758 moles of HNO3. What we don't know is the volume of the HNO3, but with a quick calculation, I can find we need 0.162 liters of HNO3 once I solve for X. And if I want to convert that to milliliters, it'll be 162 milliliters of HNO3. Either way you write this is fine as long as you give me the right unit with it. Okay. All right. Next, we have a situation where we want to know how many grams of CaOH2 are needed to neutralize 25 mils of 0.1 molar HNO3. So once again, we need to get moles from this information. So from this HNO3, we're going to say molarity equals moles over liters. The molarity is 0.01 molar HNO3. We don't know the moles, but we do know the liters. Changing milliliters to liters gives me 0.025 liters. If you're not sure how I keep changing milliliters to liters, I'm simply dividing by 1,000. That's all I'm doing. Okay. All right. So now we have 0.025. I said it right. I wrote it wrong. 0.0025 moles of this HNO3 solution. Now that we know how many moles we have, we can say, using the equation given me, that 2 moles of HNO3 are going to produce 1 mole of this. So 2 moles of HNO3 are going to produce 1 mole of CaOH2, giving me 0.0125 moles of the calcium hydroxide. Now that I know how many moles of calcium hydroxide I need, I can go further. In fact, you know what? I'm going to back this up because I just realized I could have done this. You don't have to erase. Actually, you know what I'm going to do? I'm going to show you the way I've written it so that you don't have to erase, and then I'll go back and show you what I could have done. So I'm going to take this moles of calcium hydroxide, and I know for every 1 mole of calcium hydroxide, I have a number of grams of 74.1 grams of this calcium hydroxide using my molar mass, which gives me 0.0926 grams of calcium hydroxide. So this is my final answer to the correct sig figs, and that's all she wrote. Now I'm about to erase a little bit of this just to show you what could have happened. What I could have done, well, if my thing will let me erase, there it goes. What I could have done is instead of saying equals, instead of saying equals, I could have just put this right here. Okay, my computer's getting hot, so it's slowing down. I could have put that right there because this dropped down, and I could have made it one big problem. I didn't have to do the extra writing. Okay, that is it for this video. I'm going to show you the third and last stoichiometry video on limiting reactants on the next video.